Assalamu alaikum. Welcome to lecture number 32 of the course on statistics and probability. Students, you will recall that in the last lecture, I started the third and last segment of this course, that of statistical inference. And in this regard, the very first concept that I dealt with in some detail was the concept of the sampling distribution of X bar. We discussed that the mean of the sampling distribution is equal to the population mean. The standard error of this sampling distribution is equal to the population standard deviation divided by the square root of the sample size in that situation where the finite population correction is not required. And towards the end of the lecture, I discussed with you an extremely important theorem known as the central limit theorem. You will recall that according to this theorem, the sampling distribution of X bar approaches normality as the sample size small n tends to infinity. Students, let us begin today's lecture by discussing a real-life example and a real-life application of this particular concept. As you now see on the screen, suppose that a construction company has 310 employees who have an average annual salary of rupees 24,000 and the standard deviation of the annual salaries is rupees 5,000. Suppose that the employees of this company launch a demand that the government should institute a law by which their average salary should be at least rupees 24,500, and suppose that the government decides to check the validity of this demand by drawing a random sample of 100 employees of this company and acquiring information regarding their present salaries. What is the probability that in a random sample of 100 employees, the average salary will exceed rupees 24,500 so that the government decides that the demand of the employees of this company is unjustified and hence does not pay attention to the demand, although in reality it was justified? Students, आपने देखा कि ये कितना इंटरेस्टिंग प्रॉब्लम है. इसमें हम ये अस्यूम कर रहे हैं कि जो एक्चुअल फिगर्स हैं वो वही हैं जो कि एम्प्लॉइज कह रहे हैं, लेकिन जब गवर्नमेंट ने साइज 100 का सैंपल ड्रॉ किया तो अगर उस सैंपल के अंदर एवरेज सैलरी जो है वो 24,500 से ज्यादा आ जाए तो जाहिर है कि गवर्नमेंट ये समझ सकती है कि द डिमांड इज अनफाउंडेड. Let us see how we are going to solve this problem. As you now see on the screen, the sample size 100 is large enough to assume that the sampling distribution of X bar is approximately normally distributed with mean and standard deviation given as follows. Mu X bar is equal to mu, and that we already know is rupees 24,000, and sigma X bar is equal to sigma over square root of n multiplied by the square root of capital N minus small n over capital N minus 1. And putting the values of the population standard deviation, capital N and small n, sigma X bar comes out to be rupees 412.20. Students, आपने देखा कि इस एग्जाम्पल में हमने स्टैंडर्ड डिविएशन ऑफ एक्स बार के लिए वो फॉर्मूला अप्लाई किया है which is valid in the case of sampling without replacement from a finite population. आपने देखा कि population size is only 310 और जो sample size है that is 100. So it is obvious that the sample size is approximately 1/3 of the population size, and therefore it is much bigger than 5% of the population size. और पिछले लेक्चर में मैंने आपसे यही कहा था ना कि अगर सैम्पल साइज लेस देन 5% of the population size हो, then we say that this FPC is not required because it is approximately equal to 1. यहाँ पे तो definitely not, because 310 minus 100 over 310 minus 1 is not going to be equal to 1. Now, we have found the standard deviation and the mean of the sampling distribution of x bar. Question क्या है? What is the probability that my x bar will be greater than rupees 24,500? And students, I will remind you of the lecture on the normal distribution. चूंकि हम कह रहे हैं कि according to the central limit theorem, our distribution here is approximately normal. Therefore, we are going to find this probability by computing the area under the normal distribution. As you will recall, in the lecture on the normal distribution, that is lecture number 30, I discussed with you the process of standardization. And as you will remember, the formula was Z is equal to x minus mu over sigma. इस फॉर्मूले को याद रखने का आसान तरीन तरीका क्या है? यह है कि आप कहें कि Z is equal to the variable minus its mean divided by the standard deviation. जो भी वेरिएबल है उसका मीन सब्ट्रैक्ट कर दीजिए और इस क्वांटिटी को डिवाइड कर दीजिए by the standard deviation. So, students, how are we going to apply this concept in this particular situation? As you know, in this situation, our variable is not x but x bar. So, our formula becomes Z is equal to x bar minus mu x bar over sigma x bar. आपने देखा कि बुनियादी कॉन्सेप्ट बिल्कुल वही है, the variable minus its mean divided by its standard deviation. And as you now see on the screen, when we substitute the values of mu x bar and sigma x bar in this formula, we obtain Z is equal to x bar minus mu over sigma over square root of n in that particular situation where we do not require the FPC, and in the situation where we do require this quantity, Z is equal to x bar minus mu over sigma over square root of n multiplied by the square root of capital N minus small n over capital N minus 1. All right, normal distribution है हमारे पास, the distribution of x bar, और वो point भी हमें मालूम है जिसके beyond area हमें चाहिए. The point is 24,500. x bar की इसी value से आगे का area हमको चाहिए ना, because the probability that we wish to compute is the probability that in my sample of size 100, x bar will be greater than or equal to rupees 24,500. और अभी अभी हमने standardization formula भी देख लिया. So, what are we going to do? We are going to convert this particular value of x bar into Z by this formula. And as you now see on the screen, we obtain Z is equal to 24,500 minus 24,000, and this expression divided by 412.20. And solving this expression, Z comes out to be 1.21. Hence, we need to compute the area between Z is equal to 1.21 and plus infinity. Now, according to the area table, we are able to find the area between z is equal to 0 and 1.21, and we find that this area comes out to be 0.3869. Since the total area under the normal curve from z is equal to 0 to z is equal to plus infinity is 0.5, hence subtracting 0.3869 from 0.5, we obtain the area under the curve from z is equal to 1.21 to plus infinity, and this area comes out to be 0.1131. Students, ये जो आंसर हमने ऑब्टेन किया है 0.1131, इसको हम किस तरह से इंटरप्रेट करेंगे? Obviously, 0.1131 means 11%, और इसका मतलब ये हुआ that the probability is only 11% that in a random sample of size 100, the mean of the sample x bar will exceed rupees 24,500. इसका मतलब ये हुआ कि 89% चांस है कि ऐसा नहीं होगा, and we can say that the probability is high that the government will consider the demand of the employees of this particular company. All right, the next concept that I will discuss with you is the sampling distribution of P hat, where P hat denotes the proportion of successes in the sample. What we are dealing with here is a binomial population in which every element can be classified as either success or failure. And if we draw a sample out of this population, then of course in the sample also every element can be classified as success or failure. So in this situation we obtain a sampling distribution which also has very important properties, just as we had in the case of the sampling distribution of x bar. Let me explain this concept with the help of an example, as you now see on the screen. Suppose that a population consists of 6 values 1, 3, 6, 8, 9 and 12. If we regard the occurrence of an even number as success, then we find that the proportion of successes in this population is 3 by 6, and that is 1 by 2, because there are 3 even numbers in this population and they are 6, 8 and 12. Now, if we draw all possible samples of size 3 without replacement from this population, then what will be the salient features of the sampling distribution of P hat? Students, in order to solve this question, we have to proceed step by step exactly the same way as we did when constructing the sampling distribution of x bar. सबसे पहली बात यह है कि हमारा population size है 6 और हमारा sample size है 3. Now, since we are sampling without replacement, the total number of samples of size 3 that can be drawn from a population of size 6 is 6C3, and that is equal to 6 factorial over 3 factorial into 3 factorial. And students, if we solve this expression, the total number of samples, as you now see on the screen, comes out to be 20. Now, what are these 20 samples? As you see on the slide, the samples are 136, 138, 139, 1312. 168, 169, 1612, 189, 1812, 1912, and so on. Students, मैंने आपसे last lecture में भी यह बात कही थी that it is very important that when you want to construct the list of all possible samples, you go in a very systematic manner. अभी मैंने आपके सामने जो samples present किए, आप देखिए कि उसके अंदर एक पैटर्न था. हमने पहला नंबर 1 कंसिडर किया और उसके साथ सबसे पहले 3 जो नंबर है उसको मिलाकर उसके साथ थर्ड नंबर जो है वो मुख्तलिफ नंबर हमने अटैच किए. जब 1, 3 के तमाम पॉसिबल ग्रुप्स मुकम्मल हुए, देन वी वेंट टू 1, 6 और 1, 6 के साथ जो कुछ पॉसिबल था वो हमने लिखा. एंड आफ्टर दैट वी वेंट टू 1, 8. जब 1 का तमाम ग्रुप जो है वो कंप्लीट हो जाएगा, उसके बाद we will start with the number 3. And as you now see on the slide, we have, after the first 10, which have 1 in the very beginning, the 11th one, 3, 6, 8, 3, 6, 9, 3, 6, 12, and then 3, 8, 9, 3, 8, 12, and then 3, 9, 12. अब 3 के तमाम ग्रुप्स मुकम्मल होने पर we start with the number 6 and we have 6, 8, 9, 6, 8, 12 and then 6, 9, 12. Finally, the last triplet is 8, 9, 12. अगर आपकी confusion अभी दूर नहीं हुई तो आप इस तरह से देखिए. We can write the numbers 1, 3, 6, 8, 9 and 12 in a row, and then you can start attaching an arrow starting from 1 with the other ones. So you can have 1, 3, 6, 1, 3, 8, 1, 3, 9 and 1, 3, 12. और इसी तरह से you can then have this other ones 1, 6, 8, 1, 6, 9 and so on. What we are interested in, students, is the sampling distribution of p hat, where p hat represents the proportion of even numbers in the sample. इसलिए कि इस एग्जाम्पल में हमने even number को success कहा है. So, as you now see on the screen, for the very first sample 1, 3, 6, there is one even number and that is 6, and there are 2 odd numbers, and hence the proportion of even numbers in this particular sample is 1 by 3. Similarly, for the second sample, p hat is equal to 1 by 3, but for the third one, we find that there is not even a single even number in the sample, and hence the proportion of even numbers is 0 by 3, and that is equal to 0. Similarly, you can compute the proportion of even numbers for every one of those 20 samples, and we find that the proportion 1 by 3 as well as the proportion 2 by 3 is repeated many times. Hence, we are interested in constructing the frequency distribution of p hat, and doing so, we find that the proportion 1 by 3 occurs 9 times, and the proportion 2 by 3 also occurs 9 times. But the proportions 0 and 1, each of them occurs only once, and thus we find that the sum of the column of frequencies is 20, exactly the same as what it should have been, because the total number of samples that we drew was 6C3, and that is equal to 20. देखा आपने कि ये बिल्कुल वही प्रोसीजर है जो हमने सैम्पलिंग डिस्ट्रीब्यूशन ऑफ x बार के वक्त अडॉप्ट किया था. And you will recall that after finding all these frequencies, we can divide each of them by the total frequency, and those numbers represent the probabilities of those particular values of p hat. As you now see on the slide, the probability that p hat will be equal to 0 is 1 by 20. The probability that the proportion of even numbers in our sample is 1 by 3. This probability is 9 by 20. The probability of p hat equal to 2 by 3 is also 9 by 20, and that for p hat equal to 1 is 1 by 20. If we draw the graph of this particular sampling distribution of p hat, students, we find that it is absolutely symmetrical, as you now see on the slide. Next, we are interested in finding the mean and the standard deviation of this particular sampling distribution. The formula for mu p hat, that is the mean of the sampling distribution of p hat, is sigma p hat into f of p hat, very similar to the formula that we had in the case of the sampling distribution of x bar. Also, the formula for the variance of the sampling distribution of p hat is sigma p hat square into f of p hat minus sigma p hat into f of p hat whole square. In the case of the sampling distribution of x bar, we had a very similar formula. Sigma square x bar at that time was sigma x bar square into f of x bar minus sigma x bar into f of x bar whole square. Students, I hope that you have been able to see the similarity between the two situations. And now, if we apply these quantities in our example and we compute the relevant quantities, we find, as you now see on the slide, the mean of the sampling distribution of p hat comes out to be 10 over 20, and that is 0.5, and the variance of the sampling distribution is 1 over 20, and that is 0.05. Of course, if I take the square root of 0.05, I will obtain the standard deviation of the sampling distribution of p hat, which is also called the standard error of p hat. अच्छा, आइए अब देखते हैं कि ये जो मीन हमने निकाली है 0.5, क्या एग्जैक्टली यही आंसर हमें मिलना था अगर हम इसको लोकेट करते ऑन द ग्राफ. आपको याद है ना, इट इज एब्सोल्युटली सिमेट्रिक, सो द मीन हैज टू बी इन द एग्जैक्ट सेंटर ऑफ दिस पर्टिकुलर डिस्ट्रीब्यूशन. तो हमारी डिस्ट्रीब्यूशन में p हैट की वैल्यूज क्या थी? 0, 1 by 3, 2 by 3 एंड 3 by 3, दैट इज 1. तो दरमियान वाली जो दो वैल्यूज हैं स्टूडेंट्स, 1 by 3 और 2 by 3, उनका जो मिडल है, व्हाट विल दैट बी? 1 by 3 plus 2 by 3 divided by 2, and is it or is it not exactly equal to half? Just decide for yourself. And the other point that I would now like to convey to you is that there are some very important relationships between the mean of the distribution of p hat and p, the proportion of successes in the population. Also, relationships between sigma p hat, that is the standard error of p hat, and p and q, the proportion of successes and failures in the population. As you now see on the slide, the relationships are, number 1, mu p hat is equal to p, and number 2, sigma p hat is equal to square root of pq over small n, and this whole quantity multiplied by the square root of capital N minus small n over capital N minus 1. Of course, this particular formula is valid if we are sampling without replacement from a finite population, but if we sample with replacement, then our equation is sigma p hat is equal to square root of pq over small n, because in this situation the finite population correction factor is not required. Substituting the values of mu p hat, p, q, capital N and small n in these equations, students, as you see on the slide, we find that both the equations valid in this situation are verified. Students, आपने देखा कि मीन और स्टैंडर्ड एरर की बात बहुत सिमिलर है जैसे कि सैम्पलिंग डिस्ट्रीब्यूशन ऑफ एक्स बार के केस में हमने डिस्कस किया. नाउ व्हाट वाज द एक्सट्रीमली इंपॉर्टेंट थर्ड प्रॉपर्टी in case of the sampling distribution of x bar? I will remind you of the central limit theorem, according to which the sampling distribution of x bar approaches normality as the sample size tends to infinity. In the case of the sampling distribution of p hat also, students, we find that this distribution tends to normality as n tends to infinity. And the rule of thumb in this connection is that if both np and nq are greater than or equal to 5, then we can approximate the binomial sampling distribution of p hat by the normal distribution. Let me now explain this to you with the help of an interesting example. Suppose that 10% of the 1 kilogram boxes of sugar in a large warehouse are underweight. Suppose a retailer buys a random sample of 144 of these boxes. What is the probability that at least 5% of the sample boxes will be underweight? In order to solve this problem, the first point to be realized is that the sample size 144 is large enough to assume that the sample proportion p hat is approximately normally distributed. According to the relationships that I mentioned earlier, the mean of this sampling distribution is given by mu p hat is equal to p, and that is equal to 0.10, because we have the information that 10% of the boxes are underweight. Similarly, the standard error of p hat is equal to the square root of pq over small n, and this is equal to 0.10 into 0.90 divided by 144, the square root of this entire quantity, and this comes out to be 0.025. Students, यहाँ पे आप नोट करें कि standard error के लिए the formula that I applied is square root of p hat q hat over small n, और इसके साथ finite population correction factor square root of capital N minus small n over capital N minus 1 मैंने इस्तेमाल नहीं किया. इसकी क्या वजह है? अगर आप इस प्रॉब्लम में जो पहली स्टेटमेंट है उस पर गौर करें तो आप देखेंगे कि इट विल बी ऑल राइट. हमने कहा था कि इन अ लार्ज वेयर हाउस इट हैज बीन फाउंड दैट 10% ऑफ द बॉक्सेस आर अंडरवेट. जब लार्ज वेयर हाउस की बात हो रही है तो इसका मतलब है कि thousands upon thousands of boxes are being prepared. Lihaza, the population size is very large as compared with the sample size, which is 144, and we can say that as if we are sampling from an infinite population. और आपको याद होगा कि ऐसी सिचुएशन में we do not require the finite population correction. इस प्रॉब्लम में what are we trying to determine? Question ये था, what is the probability that in a sample of size 144, the proportion of boxes that are underweight will be at least 5%? यानी कम से कम 5% होंगे underweight. तो इसको हम मैथमेटिकली किस तरह से एक्सप्रेस करेंगे? As you now see on the slide, what we want to find is the probability that p hat is greater than or equal to 0.05. Students, there is a very important concept that is to be discussed here, and that is the concept of continuity correction. Whenever we approximate the discrete binomial distribution by the continuous normal distribution, we need to apply what is called continuity correction. उसकी वजह ये है कि discrete variable x जो है 0, 1, 2 and so on, उसको हम convert कर रहे हैं into a continuous variable by applying this correction. And for example, the number 1 is replaced by the interval 0.5 to 1.5, and the value 2 of the variable x is replaced by the interval 1.5 to 2.5. इस तरह से हम proceed करें तो हम जो probability compute करना चाहते हैं उसमें भी हम apply करेंगे ये correction. And in this particular scenario that we are discussing now, since I am not talking about the random variable x, which represents the number of successes in my sample, rather I am talking about p hat, which is x over small n, the proportion of successes in my sample, x over small n, number of successes divided by the total sample size. Zahir hai, this is the proportion of successes in my sample. चूंकि इस वक्त मैं इसकी बात कर रही हूं, इसलिए वो जो continuity correction है वो सिर्फ प्लस या माइनस हाफ के जरिए नहीं accomplish होगी, बल्कि we will either subtract or add 1 over 2n, यानी हाफ के साथ नीचे n भी attach होता है, because it is x over n that we are trying to apply this correction to. Therefore, in this particular example, as you now see on the screen, the probability that p hat is greater than or equal to 0.05 will be found by computing the probability that p hat is greater than or equal to 0.05 minus 1 over 2 times 144, because in this example the sample size is 144. यहाँ पे ये नोट करें कि मैंने माइनस किया है और उसकी वजह यह है कि मुझे एरिया कंप्यूट करना है to the right of this value that I am interested in. 0.05 को जब हम expand करेंगे तो थोड़ा सा पीछे को और थोड़ा सा आगे को expand होगा. मुझे एरिया आगे का निकालना है और मुझे कवर करनी है वो मिनिमम एज जहां से मुझे आगे का एरिया निकालना चाहिए, इसलिए आई विल सब्ट्रैक्ट. लेकिन अगर इसके बरक्स कोई ऐसा प्रॉब्लम होता जहां पे मैं कहती कि आई वांट टू कंप्यूट द प्रोबेबिलिटी दैट p hat इज लेस देन और इक्वल टू अ सर्टेन वैल्यू, वहां पे मैं स्टूडेंट्स ऐड करती 1 over 2n. Now, going back to this example, we have the probability that p hat is greater than or equal to 0.05 minus 1 over 2n. This is equal to the probability that p hat is greater than or equal to 0.05 minus 1 over 288. Now, we have to find the area beyond this particular value. And students, आपको पता तो है कि जब कभी भी आपको normal curve के अंदर area compute करना है, the first step is to standardize your variable and to convert it to z. And what is the formula for standardization? The variable minus its mean divided by its standard deviation. So, in this particular example, as you now see on the screen, we have z is equal to p hat minus 0.10 divided by 0.025, and substituting the value 0.05 minus 1 over 288, we obtain z is equal to minus 2.14. So this is the z value beyond which we have to find the area under the normal distribution. So we are required to compute the area under the standard normal curve to the right of z is equal to minus 2.14. As explained in lecture number 30, we will first find the area between z is equal to 0 and z is equal to plus 2.14, and that comes out to be 0.4838. We know that because of the absolute symmetry of the normal distribution, the area from 0 to minus 2.14 will also be 0.4838, and adding this area to 0.5, which is the area between z equal to 0 and plus infinity, the total area comes out to be 0.9838. What is the interpretation of this particular result that we have obtained? Students, we can say that the probability is as high as 98% that at least 5% of the boxes in our sample of size 144 will be underweight. So, अगर इस मुल्क में ऐसी कोई लॉ है कि जिसके तहत not more than 5% of the boxes should be underweight, तो फिर इस warehouse को तो काफ़ी ज़्यादा problem आ गई ना? The probability is as high as 98% that at least 5% of the boxes will be underweight, whereas in reality, in that particular warehouse, as many as 10% of the boxes are underweight. So they cannot get away with it. Students, the sampling distributions that we have considered up till now pertained to that situation where we have only one population and we are drawing samples of a particular size from that one population. Let us now consider the situation where we are sampling from two populations. In this regard, I will be discussing with you the sampling distribution of the differences between sample means, that is, the sampling distribution of x1 bar minus x2 bar. Also, we will be talking about the sampling distribution of p1 hat minus p2 hat. Let us begin with the first one, and I will explain it formally as you now see on the screen. Suppose we have two distinct populations with means mu1 and mu2 and variances sigma 1 square and sigma 2 square respectively. Let independent random samples of sizes n1 and n2 be selected from the respective populations, and let us compute the differences x1 bar minus x2 bar between the means of all possible pairs of samples that we can have. Then a probability distribution of x1 bar minus x2 bar can be obtained, and such a distribution is called the sampling distribution of the differences between sample means. आपने देखा कि ये तो और भी ज़्यादा इंटरेस्टिंग सिचुएशन पैदा हो गई. अब हमारे पास एक सेट ऑफ मीन्स है x1 बार और एक और सेट ऑफ मीन्स होगा x2 बार, एंड देन we will find the differences between x1 bar and x2 bar for all possible combinations of x1 bar and x2 bar. So, let me explain this to you with the help of a very simple example. As you now see on the slide, suppose that we draw all possible random samples of size 2 with replacement from a finite population consisting of the values 4, 6, and 8. Similarly, let us draw all possible samples of size 2 with replacement from another finite population consisting of the values 1, 2, and 3. Find the possible differences between the sample means of the two populations and construct the sampling distribution of x1 bar minus x2 bar. All right, हमारे पास दो बहुत ही small size की populations हैं and we have kept them small so that this example is small, otherwise it will be quite lengthy. The first population is 4, 6, 8. इसमें से आपने sample draw करने हैं of size 2. But remember, if we are sampling with replacement, the total number of possible samples is n raised to n, 3 raised to 2, and that is 9. Similarly, from the other population, again, population size is 3, sample size is 2, and the total number of samples that we can draw is 3 raised to 2, and that is 9. Now, what are these 18, 9, and 9 samples? Let us see them on the screen. From the first population, the samples are 4, 4, 4, 6, 4, 8, 6, 4, 6, 6, 6, 8, and 8, 4, 8, 6, 8, 8. On the other hand, from the second population, the samples are 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, and 3, 1, 3, 2, 3, 3. Students, आपने देखा कि हमारे पास नंबर रिपीट हो रहे हैं, यानी मिसाल के तौर पे 1, 1, 3, 3, तो इसमें तो कोई प्रॉब्लम नहीं है ना. इस वक्त we are not sampling without replacement, we are sampling with replacement. आपने 1 निकाला, वापस डाल दिया, दोबारा से 1 आ जाए तो जाहिर है कि आपका सैंपल बनेगा 1, 1. Now we have 9 samples from the first population, 9 from the second, and therefore we have 9 values of x bar from the first population, and we denote these sample means by x1 bar. Similarly, we denote the 9 sample means of the 9 samples that we drew from the second population by x2 bar. Hence, as you now see on the slide, we have x1 bar as 4, 5, 6, 5, 6, 7, and 6, 7, 8, whereas x2 bar is 1.0, 1.5, 2.0, 1.5, 2.0, 2.5, and 2.0, 2.5, and 3.0. All right, no sample means plus no sample means. तो क्या हम 18 differences की बात कर रहे हैं students? No, we are actually talking about 9 into 9, 81 possible differences between x1 bar and x2 bar. And as you now see on the screen, these 81 possibilities are as follows. If we write the values of x1 bar in the top row and the values of x2 bar in the first column of a bivariate table of the form that you now see, we will have 4, 5, 6, 5, 6, 7, and 6, 7, 8 on the top, and we will have 1.0, 1.5, and so on in the first column of the table. Now, I will be subtracting every value of x2 bar from every value of x1 bar, and by doing that, I will be obtaining 81 differences which I will be writing in the body of this table. In the very first cell, I will write 4 minus 1.0, and that is equal to 3.0. Let us take another cell. Let us take the cell corresponding to the third column and the fourth row of this table. And students, you note that in this situation, I should be subtracting 1.5 from 6. By doing that, I obtain 4.5, and this is exactly the value that we have written in that particular cell. All right, देखा आपने? 9 from one and 9 from the other have given us 81 possible differences between x1 bar and x2 bar. अब जाहिर है कि this is a big pile of numbers, and we would be very interested in forming a frequency distribution so that these numbers are arranged in a compact form. And students, if we do that, we obtain the picture that you now see on the screen. We have a column of x1 bar minus x2 bar, which can be denoted by small d. Of course, d means difference. And the values in this column are 1.0, 1.5, 2.0 and so on. ये वही values हैं जो हमारी bivariate table के अंदर पाई जाती हैं. Now, after we do the tally method and tally every one of the 81 values in this table, the frequencies come out to be 1, 2, 5, 6, 10, 10, 13, 10, 10, 6, 5, 2, and 1. Students, I hope that you have realized that even if we do not draw the line chart of this particular distribution, it is absolutely symmetric, and we are able to say this because if we place a mirror horizontally against the value d equal to 4.0, we see that the frequencies above this mirror are the mirror image of the ones below. Dividing every one of these frequencies by the total frequency 81, we obtain 1 by 81, 2 by 81, 5 by 81, and so on. And students, these numbers represent the probabilities of the various values of d. This particular distribution is called the sampling distribution of d, or more appropriately, the sampling distribution of x1 bar minus x2 bar. What are the basic properties of this particular sampling distribution? Students, we find that the mean of the sampling distribution of the differences between sample means is equal to the difference between the population means. As you now see on the slide, this can be expressed mathematically as mu x1 bar minus x2 bar is equal to mu1 minus mu2. And this formula is valid regardless of whether we are sampling with replacement or without replacement. As far as the standard deviation of the sampling distribution of x1 bar minus x2 bar is concerned, in case of sampling with replacement, we have the formula sigma x1 bar minus x2 bar is equal to the square root of sigma 1 square over n1 plus sigma 2 square over n2. And in case of sampling without replacement, this formula will be modified. Students, मैंने आपसे पहले भी कई मर्तबा कहा कि इस कोर्स में we are not doing the mathematical derivations of the various formulae, but if you are interested, you are most welcome to look them up, and you will find many of them in your own textbook. I will be concentrating here on applying them to various practical problems. And going back to the example that we were considering just now, what do we have as far as these two formulae are concerned? As you now see on the slide, the mean of the sampling distribution of x1 bar minus x2 bar, which is the same thing as expected value of x1 bar minus x2 bar. It is given by summation x1 bar minus x2 bar multiplied by f of x1 bar minus x2 bar. Since we are denoting x1 bar minus x2 bar by small d, therefore, we can say that mu x1 bar minus x2 bar is equal to sigma d into f of d, and multiplying the column of d by the column of f of d and adding these products, the answer is 324 over 81, and that is equal to 4. Also, sigma square x1 bar minus x2 bar, which is the same thing as the variance of d, it is given by the expected value of d square minus the expected value of d whole square, and that is equal to summation d square into f of d minus summation d into f of d whole square, and constructing the column of d square into f of d and adding this column and also substituting the other required values, we find that the variance of the sampling distribution of x1 bar minus x2 bar comes out to be 1.67. All right, ये तो हमने results निकाल लिए regarding our sampling distribution. लेकिन जो हमने verify करना है, उसके लिए we will need to find the mean and variance of the first population as well as the mean and the variance of the second population. As you see on the screen, applying the ordinary formulae of the mean and the variance, the mean of the first population comes out to be 6 and the variance comes out to be 8 over 3. Similarly, the mean of the second population is 2 and the variance is equal to 2 by 3. What we have to show is that mu x1 bar minus x2 bar is equal to mu1 minus mu2, and if we compute mu1 minus mu2, we find that it is equal to 6 minus 2, and that is equal to 4. And students, this is exactly what we obtained when we computed mu x1 bar minus x2 bar. Hence, this first property is verified, and as far as the second one is concerned, we now compute sigma 1 square over n1 plus sigma 2 square over n2, and substituting the values, we obtain 5 over 3. And we note that this is exactly the result that we obtained when we computed the variance of x1 bar minus x2 bar. Students, आपने देखा कि ये दो प्रॉपर्टीज वेरीफाई हो गई इस पर्टिकुलर एग्जाम्पल में, और आप ये नोट करें कि यहाँ पे ये फॉर्मूला जो है that the variance of x1 bar minus x2 bar is equal to sigma 1 square over n1 plus sigma 2 square over n2, ये इसलिए valid है because we have done sampling with replacement. अगर sampling without replacement हो तो फिर तो finite population correction factor apply होना चाहिए ना. The third point is, what is the shape of our sampling distribution? As you now see on the slide, the first point is that if the populations are normally distributed, then the sampling distribution of x1 bar minus x2 bar will be normal regardless of the sizes of the two samples. It will be normal with mean mu1 minus mu2 and variance sigma 1 square over n1 plus sigma 2 square over n2. But if we have a situation where the populations are non-normal, but the sample sizes are large, so that as a rule of thumb they are greater than or equal to 30, then by way of the central limit theorem, students, we can say that the sampling distribution of the differences between sample means will be approximately normal in this particular situation. दूसरे लफ्ज़ों में हम यही कह रहे हैं कि अगर सैम्पल साइजेस लार्ज होंगे तो फिर पहले की तरह हम इस पोजीशन में आ जाएंगे कि हम ये कह सकें कि हमारी सैम्पलिंग डिस्ट्रीब्यूशन अप्रॉक्सीमेटली नॉर्मल होगी. एंड एज अ रूल ऑफ थंब, द नंबर n equal to 30, this is regarded as the minimum size at which we can say that it is quite large enough for our sampling distribution to be approximately normal. All right, in today's lecture, I discussed with you in detail the sampling distribution of p hat, and towards the end of the lecture, we discussed that situation where we are sampling from two distinct populations, and we discussed the sampling distribution of the differences between means. I would like to encourage you to practice with this concept as much as you can, and students, in the next lecture, I will take up the sampling distribution of P1 hat minus P2 hat. My best wishes to you, and until next time, Allah Hafiz.